Let's talk about even and odd functions, and we're going to be taking a look at a couple graphs in these examples. So let's start with an even function. Even functions are symmetric with respect to the y-axis, which means if we were going to fold our piece of paper along this y-axis, then the left side of our graph is going to match up with the right-hand side. Let's go ahead and take a look at one of the points on our graph. And we're working with the y equals x squared function. So let's go ahead and look at the point 2, 4. Right, if I have an x value of 2 and I plug it in here to my function, then 2 squared is going to give me a y value of 4. So we're looking at the point 2, 4 on our graph, which is going to be right here. And if we know that our graph has even symmetry or is symmetric with respect to the y-axis, then that means that the point -xy is also on this graph. Since we're looking at the point 2, 4, then that means the point -2, 4 would also have to be on our graph. And it is. Right, I could easily fold my piece of paper along this y-axis, right, and these points would match up or lie on top of each other. We could also go ahead and work with the equation that we're given so that we can check to see if a graph is symmetric with respect to the y-axis. And when we do that, we're going to be replacing the x value with a negative x inside the equation. So let's go ahead to our equation here, y equals x squared. And I want to go ahead and replace this x with a negative x value. And then I want to go ahead and do the math on the right-hand side. And if we take negative x and we square it, remember that that's the same thing as multiplying negative x times negative x, which is going to give us a positive x squared. And so we want to go ahead and compare these two equations. Right, this was our original. And the answer we had down here at the bottom was the one after we had plugged in that negative x value. And we ended up with an equation that matches. So it's exactly the same as the original equation we started with. In this case, that would be our indicator that this function is symmetric with respect to the y-axis. Now let's go ahead and take a look at an odd function. We're going to be working with the equation y equals x cubed. And this function is odd. It's going to have symmetry with respect to the origin. Both of these words start with letter O, so that's a nice way to remember that. And if you're taking a look at the picture of your graph, if you take that image on your piece of paper and you turn your piece of paper upside down, so you're rotating it 180 degrees, if that image looks exactly the same right side up as it does upside down, then your graph is an odd function or is symmetric with respect to the origin. If we're working with some points, let's go ahead and work with the point 1, 1 on our graph. Right, if I have a point 1, 1 on my graph and I know this graph is symmetric with respect to the origin, then that means my negative x value and my negative y value should also be on that graph. So in this case, the point -1, -1 would also be on our graph, which is down here. So let's go ahead and label these. Here's my point 1, 1, and this is my point -1, -1. If we're working with equations, we have the equation y equals x cubed. And we want to go ahead and test this to see if it's symmetric with respect to the origin. then I can go ahead and replace my x value with a negative x, and I can replace the y value with a negative y. Alright, so let's go ahead and replace the x value first. Here's my negative x, and we'll plug it in. And I'll plug in negative y in place of this y value. And all I want to do here is simplify the left side and simplify the right side. So if I'm working with the right-hand side of my equation, I've got negative x times negative x times negative x. It's the same thing as negative x, the whole thing cubed. And if I multiply this right-hand side out, I have 3 negative signs here, so my answer is going to be negative. And if I'm multiplying x by itself 3 times, I've got x cubed. Right, and I can go ahead and divide both sides here by negative 1. So this will give us the equation y equals x cubed. And remember, we want to go ahead and compare this to the original equation that we started with. And you're going to notice here that these equations match. So this is an example of a function that is symmetric with respect to the origin.